Good afternoon, everyone. I'm Josh Mandel. I'm the Chief Architect at Microsoft Healthcare, and I'm excited to get to talk with you about the work that we've done over the course of the last 2 years in bulk data. So this is work that started with the Smart Health IT project at Boston Children's Hospital, work that we've done in the Argonaut community, and then the broader FHIR community. And I'll take you through the story, some of the goals, I'll give you a sense of where we are today, and what we're doing moving forward. So the slide deck here is linked at the URL in the top right corner, bit.ly/FHIR-bulk-data. And you might want to follow along just because there are a set of links from the deck out to some of the tools and reference implementations, as well as the specifications that we'll be talking through. Okay. So a few examples or motivations just to set the scene here. So these are some examples that Dan Gottlieb compiled. Dan has been my co-lead on the FHIR bulk data effort, and took a few conversations that he had had. So one with a big academic medical center that was looking to take progress notes from various kinds of third-party clinics and bring them into the EHR environment. Or another looking to do integration between population health tools and electronic health record systems. So you've got a system of record and then a population health tool that's supposed to help you identify cohorts and manage interventions across those different cohorts. Or a startup that wants to take various kinds of health data from a clinical record and train up machine learning models. And many of these are examples that we've heard about in other talks at DevDays. There's very common kinds of integration patterns here that require access to data at scale. Some of these same kinds of technologies are useful for integrating healthcare payers with healthcare providers, or processing claims in a scalable fashion, or just doing data warehousing inside of an organization to support research. You want to give researchers a way to do queries across patients. That kind of cohort definition problem is very similar to the cohort definitions that you might do in care coordination. So there's a variety of use cases that all sort of hinge on this kind of data flow, where you want access to a fairly large population all at once. And the truth is that this kind of thing happens all the time today. In a lot of senses, it's a completely solved problem. Sharing data at the population health level or at the population level is just commonplace. The problem is that it gets solved over and over again in different ways. So the really common scenario is you've got an application or some use case that needs access to particular data extracts. First thing you do is you sit down and you negotiate with the source of data about exactly what you need to get. And you define a bunch of CSVs and you say, well, I need a column that represents a patient's birth date, and I definitely need a column for gender, and I'd really like one for smoking status. And the hospital will say, well, we don't have smoking status. And you go back and forth in this kind of negotiation until you arrive at a set of data models. And then somebody builds, using some kind of report or query builder tool, builds a pipeline to pull those pieces of data that you need out of the system. And then all that's left to do is to agree on how often they're going to run that report for you, how often they're going to do that extract, and then how they're going to deliver it to you. So a really common thing would be you set up an FTP server or a secure FTP server or a cloud bucket, and you agree about what credentials are going to be used and how often you're going to rotate them, and then somebody just uploads the data on a regular basis. And all this stuff is cookbook, but everybody's making a different recipe every time, and that's a 3-month project if you're pretty efficient at it, to start from that negotiation to a process where you've actually got data flowing. So the question that we wanted to ask with FHIR bulk data was, could we use some of the building blocks we already have in FHIR to do better? So we don't have to make a proprietary data model every time, so we don't have to do a manual data extraction process every time, and so we don't have to come up with a special way to move data over the wire. And the FHIR APIs that we have sort of today, or the initial FHIR APIs, work really well for one patient at a time. They're good for fetching things that you can get back synchronously. You get a bundle of patients, a bundle of observations. It works really nicely for small data, but it didn't really work very well at the population level. It would require sort of issuing a whole bunch of queries in series to go all the way from the beginning of a very, very long search result to traverse those pages to get to the very end. And there's opportunities to do that much more efficiently. So the goal was to say, well, let's use what we've got in FHIR already. There's, first of all, the resource definitions. These are incredibly powerful data models that represent a broad consensus among the community. Let's not go back and have a conversation every time. Let's actually use those data models. FHIR has this operations framework, which is kind of a remote procedure definition in the facility, where you can define new custom operations inside of a FHIR server. So we said, great, let's use that. Let's build on top of that existing framework. And then we looked at this as an opportunity to build out a set of smart on-fire specifications for what we call backend services. So how do we make sure that one system can connect to another in a secure way where we specify in a standard fashion exactly what's going over the wire, how do you get an access token, how do you tell what that access token is good for, all those kinds of things. Just to give you a sense of how we define scope, we didn't want to address things like how we do de-identification or how we do vocabulary coding and translations or even in some sense downstream client-specific encryption. But instead, we wanted to define a building block that many fire servers would be able to implement, something with the lowest barrier possible to implementation, so that if a health system wanted to start composing that building block with other kinds of tools like a de-identification transform, that we could compose those things as a pipeline. So you can rely on your EHR to spit out identified data. You can plug in a de-identification pipeline module and then connect to that module with your application, with your sort of ETL application. So the goal was we didn't want to get each electronic health record vendor, for instance, or every fire server in the cloud to have to support a common set of these modules. Better to leave those things composable. So we tried to keep the scope narrow from that technical perspective. And then also kind of socio-technically, we didn't want to address things like a legal framework for data sharing. Even though many of the participants in these kinds of ecosystems need those kinds of frameworks, we said we're going to try to just focus on the technical work here. We did not try to address things like real-time data streaming, even though that's super important, and it would be very valuable to subscribe to data at the population level. But we do have other projects going on to try to flesh out these ideas around near real-time data subscriptions. But the focus here was really on replacing bulk file-based exports that happen every day with something that's a little bit more fire-friendly. So we left out things like data transformations. We left out of scope patient matching, even though especially when two organizations want to share data across their boundaries, they often identify patients in different ways. They have each collected different information about the patients in their population. But we said, that's out of scope. It's an important problem, but it's not part of bulk data export. So any questions about scope before I dig into the architecture and talk about some of the tools? OK. So let me just walk you through the solution. This is something that we have standardized in an implementation guide that was published in August of this year. And it was the smallest thing that we thought might possibly work. So basically, there's two actors. There's a bulk data client and a bulk data server. And you can see in the labels here, the client is actually the destination. This is where the data will eventually come to. And the server is the data source. This is where the data are at the beginning of the interaction. And the client asks the server to begin an export job. So we call that a kickoff request. The client says, please start exporting data. And there's a few parameters to that export request that the client sends along. So first of all, there's a couple of levels at which the export can begin. One is data at the level of the whole server. So this is particularly interesting if you have like a cloud fire server and you want to do a backup or you want to do a migration, where there the task is really just get out all the resources that the server knows about and persist them somewhere so I can transfer them elsewhere. Another use case, though, is at the level of clinical data. Let me have all of the information about all the patients in your server. So you can do an export at the level of what we call the patient resource type. So just to be clear, this is not data about one patient. This is all the data, all the clinically relevant data about the patients in your server. And then finally, there's data at the group level. So if you've defined a group of patients that maybe are part of a specific insurance plan or a specific research cohort or have participated in a specific consent arrangement, you can do export for all the clinical data on patients in that group. So it's one level of indirection. It's not all the patients, a specific group. And then part of that query becomes a header called the prefer header, where the client says, I would prefer that you respond async. So that's the respond async prefer header. And that is telling the server this is a kickoff job, a kickoff request for a bulk data access. There's a few parameters that a client can supply along with that kickoff. So one is the output format. This is the eventual format in which the exported data is going to be represented. And in the spec, we have one required data type that all servers need to support, which is ND-JSON or New Line Delimited JSON. I'll show you some examples of that in a moment. There is an optional parameter where the client can say, I only want resources that have changed after a particular date. So this becomes useful when we think about doing incremental updates. So you might do a full export the first time around and then weekly exports with a since date after that. We define an underscore type parameter, which provides a list of types of data, fire resource types that the client wants to get. And by default, if you leave this off, the server gets to provide what it considers to be sort of the right set of types to answer your query. If we're doing a group level export, there's a group ID as a path parameter. And then we have this experimental syntax, which we'll talk about just a little bit, to say, how could we do richer filtering beyond just all resources of a particular type since a particular date? And we explicitly label this as experimental because it's something we still don't understand that well, and we need to see from implementation experience sort of what works in that space. So that's the kickoff request. And the server responds with a very, very small payload, but it responds right away. So it's a synchronous response that says, OK, client, here is the location that you should go to if you want to check on the status of this request. So it responds with that content location. And it's basically an accept header, says we've accepted your job, and the location which tells the client where to go for more information. So the client keeps track of that content location, and it's going to use it for the next set of requests that it makes. So right away, it can do a GET request on that content location, and what it will receive is kind of a status report. When we specify very little about what needs to go on here, but there's a string in the XProgress header, which is a human-readable string, where the server can convey to the client, here's how done we are, or here's how much you might expect to wait. And we don't specify any more about that in a computable way. But we do provide this computable header, which is a hint to the client about how long it should wait before it polls again. So this way, the server can control behavior, and you don't get a client that is asking in a busy loop, are you done, are you done, are you done, are you done? So it can respect that 120 seconds and wait a couple minutes before trying again. And then eventually, the client will issue the same GET on this content location. And instead of receiving a status, eventually, it's going to get a response that says, we're done. So the response will have a couple headers. Yes, OK, your job is ready. Here's how long we're going to keep your results around for. So here's when your job expires. And then that response has a body as well. So this is what we call the export status response. It's got a transaction time. So this indicates the time at which the request was effectively evaluated by the server. And it replays the request itself, so a client can be sure exactly which parameters that it supplied were understood by the server. So this is actually a common pattern that we use in Fire Search, where a client, when it does a regular old search, can provide a bunch of search parameters. The server doesn't necessarily know about all those parameters, and it's not an error. The server is allowed to process the parameters it understands, as long as it responds to the client in the bundle for a search with a URL indicating which parameters it actually used. So we just do the same thing here with this request. It's a replay of what it actually understood the request to be. And then a list of output files. Each one of these is going to be a file the client can fetch subsequently. Each file has resources only of one type, but there could be more than one file for a given type. So maybe I've got a lot of observations in the server. The server can decide to break that into as many individual files as it wants to. So the server is sort of in charge of how big these files get. So each file has one type and a URL, and the client can then go along and fetch these data. There's also an opportunity to convey error results. So we use the operation outcome resource type for those error results. And the client can get a file full of error results just like it can get a file full of data. So that's what the client gets in the response. And then one by one or in parallel, the client can go and fetch the URLs from each of those files. And we'll talk about the contents of that. But once that's done, once the client has fetched all the exported data, that's the end of the interaction. And a well-behaved client can actually come back and issue a delete on the content location to signal to the server, I'm done now. It's safe to delete all those files. I won't need them from you anymore. But that's just kind of a closing step. So under the hood, what's happening? So yes, we're dealing with Fire resources. And we think that the Fire data models are actually a really good fit for this kind of thing. I think most people at this conference sort of get that already. As far as the format of those data, they're in what's called new line delimited JSON. So this is a file format where each line of the file is a complete Fire resource. And it looks a little bit like a JSON array, but without an opening square bracket and without a closing square bracket and without commas between the entries in the array. So it's just one line as a Fire resource. And of course, these resources then need to be serialized in a way that you don't have line breaks inside of the resources themselves. But parsing this thing is very simple. You just proceed to the next line break, treat what you found as a JSON resource, and repeat. So that's new line delimited JSON. There are much more efficient file formats, both in terms of computational processing time and in terms of size of the resources. New line delimited JSON is nice, not for its pure efficiency, but because of how dead simple it is. And we wanted to bake in one required format into the spec, and this was a pretty strong contender. Not only is it very simple, but it's supported out of the box by a broad array of data processing tools. So in many sort of big data platforms, you can just drop a file like this into a bucket or a file system and point to it from your favorite tools and issue queries directly against this data format. There's ongoing discussion about some more efficient, sort of schema-backed binary data formats, but we decided to leave that for a subsequent version. So that's the complete data interaction. I want to tell you a little bit about the authorization specification that we published alongside the export spec. But before I do, I should mention they do not have to be used together. So you could go and implement everything I just showed you with no authorization at all, or with whatever authorization method you like. But we wanted to publish, together with the bulk data export spec, an authorization spec that we could rely on and that we could promote because we wanted to have a standard way to do this across systems. So the goal here, similar to the way we do a smart app launch, is we weren't trying to fully automate the entire process. So app registration, for example, we left out of band. We encourage servers to look into things like dynamic registration, but we think that many servers will provide some kind of a portal, maybe a self-service portal where app developers can come and register what they've built. But we do require that every app needs to have access to a public-private key pair. So apps typically would generate those for themselves and register their public key as part of the app registration process. Or better yet, register that key with one level of indirection. So we use something called a JSON web key set, JWKS, where an app can say, here's the URL where my public keys live. And that way the app can be in charge of rotating its own keys over time. And the server can go and fetch that URL to know what the valid keys are at any given point in time. But we also provide the option that clients can just directly say, here's my public key. You don't need to go and fetch this URL. I'm just giving it to you directly. So those are both possible. And then in terms of scopes, we use the Smart on Fire scopes with what's called the system prefix here. And this indicates that we're talking about system level access. So one server connecting directly to another. There's not a user involved. There's not a single patient involved, but we're sort of at the level of machine access. And the idea is that anytime you get an access token, that's a short-lived token, so something that you might just rely on for a few minutes or the span of time that it takes to download a file or engage in one interaction, but that you can get a new access token automatically by following the right protocol. So the protocol basically looks like this. On the left, again, you've got kind of the client, which is in this context what we call a back-end service. And on the right-hand side, we've got the Fire bulk data server. And so there's this out-of-band registration step ahead of time. Maybe manually, the client developer goes and registers its client with the server. And then in band, when you want to actually kick off a bulk export request, you generate a signed token request, and the authorization server gives you back this short-lived access token that you'll use for issuing a Fire API call. And that's pretty much the level of detail I want to get into on the security front. Under the hood, we use a set of OAuth standards built on JSON web tokens and the ability to sign a request using a private key. So this work I mentioned started about 2 years ago, and I want to take you through basically a quick view of what changed as we took it through the HL7 ballot process. So over the course of this year, early in the year, we submitted the specification in its current form to HL7. The May ballot cycle brought in about 150 comments from the community, and then resolving those comments, we made a number of generally small changes, often just to the documentation, but we resolved each of those one by one and then published the final spec in August. So one thing that we added over the course of this project was this notion of a system-wide export, the export operation I mentioned that would give you all Fire resources from a server. When we first started, that wasn't really even one of the use cases that we were thinking about very actively. We were mostly focused on patient-level data or group-level data, but the notion of doing a system-level export fit in pretty well with the framework we defined, and it was an easy enough thing to specify. So that's one thing we added. We did a little bit of renaming of parameters to make their purposes more clear, and we also provided a way to get counts of the results so that a client who's looking at how many resources were in a given file would have a way to know that without having to traverse that file top to bottom. And then I mentioned this idea of an experimental parameter, the type filter query parameter, that would allow clients to specify in a more fine-grained way the data they actually wanted. I don't know that I love what we designed here, but we had a lot of discussion about what we could do, and this was the best thing we came up with. So I'll walk you through it really quickly, but I also want to say this is not something that I think any real server implementations have built yet, but we did have one community member who built a proxy that could implement this type filter on top of the generic API. So we've had a little bit of experimentation with it in the real world. But basically, without the type filter, a client that wants to do an export in a limited way might be able to say, just give me medication requests and conditions. That's all I'm interested in. And that's fine. But what if the client only wanted to focus on active medications? There's no way to say that. So by using this type filter parameter, we say, fine, a client can pass along additionally a comma-separated list of search queries that the server should use to further filter. And these things are basically ORed together. So this is saying, I want to get just medication requests in the active status. And you'll see there's some URL encoding artifacts here because, of course, this is sort of a URL that's being embedded in a URL. So you've got to encode the thing before you stick it inside. So this was the notion that we came up with, but we talked about many other design ideas for how we could do this kind of fine-grained filtering. Things like graph definition might be useful to say, start here, but traverse this graph for me. Things like the clinical quality language might be useful to say, sort of execute this set of rules against the data. There are a number of directions and patterns that folks wanted to take this in, but it's a pretty deep problem, and we realized that we could make a lot of progress even if we didn't solve this problem. We didn't want to get stuck on it. So we defined something, we labeled it very clearly as experimental, and moved on. If folks do have clever ideas about what we could do in that space, definitely come grab me. I'm still interested in exploring that space more deeply. All right, I'm going to skip the details of the authorization protocol itself, but this is what's specified in the Smart Backend Services implementation guide. And I do want to share with you some of the sort of tools and resources and community participation that we've had so far. So one is we've built a reference server. The team at Boston Children's Hospital put together this site at bulk-data.smarthealthit.org. And for those of you who saw the Smart Launcher demonstration, this will look kind of familiar in terms of the UI. But what's happening here is a little bit different. Rather than doing a user-facing Smart App launch, here we're supporting Fire Bulk Data Client. But you can configure this server to behave in a variety of ways so that you can test your client in different circumstances. You can configure it to give you either a very small number, like 10 resources per file, or a very big number, like 1 million. Maybe 1 million is not very big, but a bigger number. You can configure it to work like a Fire R2 or R3 or R4 server. You can simulate various kinds of errors, and you can simulate different sizes of database under the hood. So you can say, just pretend like you've got 100 patients in the database, or 1,000 or 1 million, and the server basically will just stream out results for a longer or shorter period of time, depending on what you've requested. And you can actually tell it how fast you want to respond. So you can say, simulate 10 seconds of file generation time or 10 minutes of file generation time, that kind of thing. And once you pick all your options from this list, you get a Fire server URL here that corresponds to a server that's configured with all the options that you just picked. Under the hood, what's happening is we're just encoding all those behaviors in a little snippet of JSON here that gets base64 encoded and stuck in the URL. But that's an implementation detail. As a developer, you treat this thing as a Firebase URL, and it's your own special server that behaves just the way you asked for. So that's a testing tool on the server side. If you're building a client, you can point it to this server. We also have a sample client. There's a web-based sample client and a command line sample client. So if you're building a server, you can point these clients to it and select exactly which types of data you want to export, and basically just hit a button and it goes. It's a pretty straightforward client implementation, and there's links to the source code for all those components on GitHub. The GUI version just lets you sort of select the specific resources you want and hit download, and eventually I'll get a few files out. So that's a set of tools. And the other tool that is work in progress, this is work that's being sponsored by the Office of the National Coordinator for Health IT in the US, is a testing tool. So a goal of the ONC has been to see broader implementation of these standards, both by electronic health record vendors as well as by payers, healthcare insurance companies, to promote data sharing in both directions, making more financial data available to provider organizations and more clinical data available to the payers. And encouraging that kind of data sharing for better healthcare value in the US. And so part of that mission then is, how do we make sure that we know if a server has implemented the API correctly? And the test suite basically goes into that. You can point it to a particular server. So I'll point it to the reference server that I just showed you a moment ago, and hit a button that's going to run a series of tests. Basically, going through a set of assertions, making sure that the API is behaving as expected. And you can test just the data APIs, you can test the authorization APIs alongside, and depending on what you've elected to test, some things will show up as skipped, otherwise things will show up as a success or a failure. And this is something that you can configure to point to your own server by adding one to the servers tab here, or you can do it, you can do it in two modes. One is publicly, so you add a server that everyone will be able to see, and one is privately, so you add something that's just visible to you in your own browser. And then it'll keep track of the current status of all the publicly registered servers. So it'll tell you at any given point in time how many tests that server is passing or failing. So that's a quick view of some of the testing tools. And I would encourage folks who are interested in these APIs to try out the reference implementation. It makes it very easy to see what's happening over the wire, and try out the testing tool as well. So at this stage, we've seen implementations from a number of organizations, including from CMS, the Centers for Medicare and Medicaid Services in the US. So this is the largest payer, representing a big fraction of the market, particularly the entire adult population in the US over age 65 is on some kind of a CMS plan. There's a number of different plans, but the most common one today is the one that has built out a FHIR bulk data server for making patient insurance history, specifically medical claims, available through these APIs. And so they've launched a couple of pilots working with healthcare provider organizations that surface this kind of claims data at the point of care. And they're doing that using the FHIR bulk data API. And they also have a program for what's called accountable care organizations. It's another kind of payment structure where one hospital or one health system is responsible for the care of a whole population of patients. So it's very helpful to have the 360-degree view of the data for that group of patients. Oftentimes, they might be receiving care outside of your health system, and the only way you know it is by learning from the insurance company that they've billed for services elsewhere. So it's an important tool for sort of care coordination. On the on the FHIR server side, we've also seen support inside of Microsoft's FHIR server. The Azure FHIR server has support in the open source repository for bulk data export. And that should be landing in the managed service soon. Happy has built out support for these APIs. IBM's FHIR server has built out support for these APIs. I think the Google Cloud server has something similar. It's not quite API compatible yet, but there's ongoing discussion about how to get there. And then some of the EHR vendors, Epic and Cerner, have been participating in our FHIR Connectathons, and they've each built proof of concept implementations, but it hasn't been totally clear exactly when they might go into production. The main consideration there is to build out these APIs in a way that performs well. Those kinds of vendors are often looking at building the APIs not on their transactional health record system, but instead on top of their population data warehouse type systems, just because those are more analytical-based systems. So that's a quick view of the current state of implementation on the server side. Let me spend just a couple of minutes talking about some future work. So one is a draft proposal for an import operation, which you could think of as kind of a complement to the export operation. And I should preface this by saying you can do an end-to-end import automatically without a special import operation. You can build a client that performs an export and loads the data into your system however you need to load the data into your system. So you don't necessarily need to standardize the import piece in order to allow end-to-end data flow. But some nice opportunities open up if you can standardize the import piece. So I've generally looked at this as a valuable piece of work, but less critical to getting data flow than export. So we've got a draft specification on GitHub. I won't go through the details of it, but I will talk about, just give you a sense of some of the use cases, which go anything from being able to import static data sets into a standalone FHIR server, to being able to do replication across servers. So you might want to have a slave server that's kept up to date with some time lag from your production FHIR server, to even synchronizing data with an EHR. So there's a variety of use cases that folks have been sharing, and we're trying to figure out exactly what we need to specify in order to make this work. One thing that we've picked up very early on as we've started writing the import specification is provenance is really important, so tracking where these data came from. If you're loading in a pile of data from an old server to a new server, do you preserve FHIR resource IDs? Do you remap them? Do you overwrite them? What happens? What guarantees can you make? I think we don't have a lot of answers yet. So far, what we've said is it's nice if you could preserve IDs. That would be like a good behavior, but we know there's going to be cases where you can't, especially if you're importing data from multiple servers into one. You might have conflicting IDs. So the other advice that we've put together is that we defined an extension that would allow you to say, pretty much just here's where the resource, this specific resource came from as part of an import operation, so that there's traceability. You can always go back and look at the set of resources that came from a particular place. So in terms of next steps, really we're pushing on implementation support for the export APIs that we've got today. We move those specs through the standards process at a pretty fair clip. We're looking at some widespread implementation support from major vendors, both in terms of cloud systems and in terms of native EHRs. We're doing some work to define an import operation alongside. And then there's this orthogonal set of concerns that I didn't mention much, but let me just share a couple details, which is group management. So I mentioned that it's very important to be able to do export about a specific group of patients, maybe a cohort for your research study. But how does that group get defined in the first place? The current export spec is totally silent on that point. The client requests export for a particular group, and we just assume that by the time that's happening, the group has been defined and defined correctly. But in a lot of real-world circumstances, you need actually an interactive API to manage that group. And there's a few different conditions. So one is the server is authoritative. So the server manages groups of patients internally, and the client can just pick one and ask for it. Sometimes it's a negotiation. So in the CMS protocol, for example, the Medicare server sort of knows about the group of patients that any given clinician is responsible for. They have an algorithm for it. They go through their billing history, and they say, all right, if you've billed for services about a particular patient in the last X months, something like 18 months, we'll consider them to be part of your group. But you as a provider can always let us know some additional patients that might be new patients in your practice that belong to your group, even though our algorithm couldn't detect it. So CMS comes up with an initial set, providers can add to the set, and they've defined a set of APIs using the FHIR group resource to do that kind of negotiation. So there's a little bit of discovery and a little bit of back and forth to tweak the group membership before an export operation. We'd love to formalize that, basically to be able to describe those different circumstances and come up with a set of implementation guides that would provide consistent behavior on managing the definition of those groups. So last slide, would love to encourage folks who are interested in this space to get involved in the community. I've already pointed to a couple of the reference implementations as well as cloud services that you can spin up and try on your own at scale. We've got some sample data sets published as well. These are basically just Cynthia export data sets that we've formatted as new line delimited JSON to make it easy to load into a server. And we're having active discussions, mostly around the last couple FHIR Connect-a-thons around the import operation. So at the end of the deck, there's a set of links to the specifications and the various demos that I showed throughout. And let me just stop there and see if there's comments or questions on what I've shown. Yeah, please.
Load a lot of data into it, it can be slow if you know, it sets all the IDs and it checks if something's already there. But if you do a fresh load, do you think there's a opportunity to specify that into that import? So if you load everything, you can give the IDs yourself and then you will improve the...
Yeah, so the question is, could the import operation be an opportunity for better performance when you're importing a large set of data? You know, there may be chances to do things like turning off indexing and doing a bulk load, and you know, there are a lot of places where you might be able to save time if there was explicit support for it. So I think the answer there is, yeah, for sure. If you know that you're building in support for something like a standardized import, then you can build in whatever special techniques you've got to make that process work well. I will also note that you probably, if you're building a FHIR server, you probably have some facility for bulk loading anyway, even if it's not a standardized operation. And so those kinds of tricks and techniques are also available, often through those proprietary interfaces. And the nice thing about a standardized interface would be you didn't have to do anything special. What I think is probably not a viable strategy for a client is doing a bulk export and then going row by row through the results and trying to do like a FHIR post to a new server for each one. That's probably not going to be viable. So the real world alternatives are, number one, do something specific to your server to get the data in, or number two, define a standardized input. Yeah, please.
What if the original export that you do since the beginning of time actually is just not possible in one chunk? Was it considered to have like a since and then until or something like that, so you can page through the original export?
Yeah, so the question is, I mentioned this since parameter that would allow you to get all the resources that had changed since a particular date, but what about the complement of that, like an until parameter, so I could sort of page for resources that had changed within a particular date range? It's something that came up in discussion, but we didn't have a hard use case for it, which is to say, when it came to doing an export, the notion of giving me all the data in your server since all time, like that was actually the core use case. And so we basically built on the assumption that servers would be able to give you all the data, and we added since as a performance operation so you could call something smaller on subsequent refreshes. So it's a coherent idea, and it's something that you can add as an extension parameter, but we didn't quite need it to get where we wanted to go.
I was going to say the use case actually I just faced is a major migration from an existing setup, and doing the export in one chunk, it wouldn't even if it lasted a week, it would blow up, and you would have to basically put a lot of resources for that server or that installation and platform in order to just extract the data out of it, because the data structures are just big and things like that. That's why I was mentioning that the original export may not work actually at all.
Yeah, so the comment was some systems might actually not be able to export all their data. So yeah, in a system like that, I would look at adding something like an until parameter, but generally the architecture that we recommend here is that the export might take a long time, but the goal would be, the server, for example, could decide to paginate this as though the client had issued 5 discrete time chunks, whatever the server would do in that circumstance, and just do all 5 and spool out those files to disk. So there's always sort of a bridge there. Other questions? Yeah.
For the type filter parameter that you talked about, I'm curious if you considered allowing like a profile URL there, so you could say something like, give me all the observations that are via my observations.
Yeah, so the question is for type filter, did we think about things like a profile URL to say, give me all of the resources of this type that match a particular profile? We talked about, so there's 2 ways to answer the question. One is the Fire Search API allows profile-based search for resources that have been specifically tagged with a profile. And so clearly you can do that with the type filter that we have. But I think you're getting at something more specific, which is like, what if that was actually the only thing that you define? The syntax could be a lot simpler, and you could just focus on profile conformance. The truth is that in the US core data sets, at least, resources are not explicitly tagged with profiles. We wouldn't have gotten a lot of mileage out of that approach. So maybe that's why we didn't. I don't know if that came up, but that might be why we didn't go in that direction. It's certainly a useful thing to do if you're working with a system where data are consistently tagged with profiles. Other questions or comments? Yeah, please.
Is the export specification prescriptive to how servers should handle updates once the export is started, but it's in progress?
Yeah, so the question is, are we prescriptive for servers about how to handle, so that the export could take a while, are we prescriptive about how to handle changes that happen sort of between when the export begins and when it ends, like new patients that get added? And we do try to be prescriptive. What we say is that the server, when it begins to process the query, generates the timestamp that I showed you. What was it called? The transaction time. And so that basically represents the beginning of the query when the server does this cutoff and begins processing. And the expectation is that no resources changed after that timestamp will be present in the export. And that transaction time then becomes something the client can replay with a since parameter, the next time it comes back. Other questions or comments? All right, well, thanks so much for your attention, and come grab me if you've got anything to talk about afterwards.